If we can achieve 10,000 cubic meters in the 25th year, then in the 26th and 27th years we can move up to 25,000 cubic meters, developing a new technology, but already with the old experience. Here you can elaborate on what useful payloads we have. It's clear, cell towers, ensuring communication.
The relationship between payload and the volume of the device is significantly nonlinear. Specifically, we're talking about the altitudes at which we need to fly in particular. We see target altitudes of 18 to 22 kilometers for ourselves, but there are tasks that require us to go lower, though not below 15 kilometers, otherwise we're in airplane territory. And there are tasks that need us to go higher. We're already talking about 25 to 30 kilometers, and even 40 kilometers. Naturally, to launch 5 kilograms to 40 kilometers, you need a significantly larger volume than for the same 15 kilometers due to the thinning of the atmosphere. Accordingly, the shell will approximately explode at an altitude of 40 kilometers in the atmosphere. Its volume simply won't be enough for the helium to expand. As for the payloads for devices over 10,000 cubic meters, these can include relay stations and scientific equipment. This equipment is necessary to ensure the duration of the flight. If we're talking about a number of months and large capacities, then it's reasonable to ensure the same energy supply of time. This is a lot of solar panels, and it's a lot of liquid hydrogen, for example.
You can even carry gas with it.
Yes, and of course we can provide one level of power, for example, for ice reconnaissance radar on a device with 10,000 cubic meters. And we can provide significantly greater power on a device with 25,000 or 100,000 cubic meters. And this is a question of resolution, a question of detection range, and a question of communication range, meaning the technological capabilities of the equipment that is there. It's a question of the number of subscribers that this device can support, because a tower weighing 60 kilograms, if I remember correctly, can serve several dozen, maybe up to 100 subscribers. If we want to cover all the tens of thousands of kilometers of area available to us in the area in which the apparatus is located and ensure comprehensive coverage, if we climb to an altitude of 20-25 kilometers, we can see hundreds of kilometers ahead. Up to 500 kilometers can be achieved in terms of radio horizon. And to provide subscribers in that area, we need the corresponding power. So, this is also a question of economics. One device can already support significantly more subscribers. We need fewer devices, and this is a question of technological capabilities.
I'm a bit stuck at the moment. There's actually a significant amount of interest in these payloads from various sectors, and numerous people and organizations are actively reaching out and communicating about it. Everyone truly needs this essential thing, and we are the dedicated team working hard to develop and perfect it for the benefit of all. Neptune project was seen. They recently launched a test capsule from the ship.
Yes, indeed, but it's always quite interesting to really launch from the sea, especially from ships. It actually turns out to be truly fascinating in the equatorial zone where they did it.
I haven't determined the volume, how much mass they lift, if they release it on a parachute, or if they bring it back. I haven't looked into it.
From the perspective of the future fate of the shell, there are different possible options. Typically, this is resolved by detaching the gas shell, which explodes at altitude after reaching the operational height, and then it just falls like polyethylene, slowing down. It's a kind of petrol parachute. It falls in a certain area, and they don't worry too much about it.
But they plan to take these tourists. It's unlikely they'll shoot off the shell with tourists on board. Most likely they'll release the gas.
Indeed, yes, they can definitely either release the gas, yes, or use parachutes. Naturally, after detaching the gas shell, the parachute opens at a certain altitude.
I'm sitting here thinking, there's one of the questions. Who else is working on this? The only one I can remember now is Neptune, which has seriously taken on this project. But they're planning to take tourists up to the stratosphere. So, weather balloons are constantly being launched into the stratosphere by all countries, thousands of them every day. They're tiny.
Yes, indeed, they are small shells made of latex.
Recently, there was a lot of noise about a Chinese long-drifting device that flew over America when they tried to shoot it down.
There are many questions about this device. If you look closely at the photos, which unfortunately are not of very good quality, you can see some angularity in the shell. If it really looks like that in the photos, then most likely it wasn't at a very high altitude, maybe just a little over 10 kilometers. It wasn't an unreachable stratosphere at 20-30 kilometers, which is a significant altitude. There was quite a bit of noise and discussion about it. In general, the question of flying these devices across national borders is quite interesting and complex. How can this be executed or carried out without in any way violating airspace? Furthermore, from a legal standpoint, the stratosphere is considered an ambiguous or blank spot in international law.
There's additional information that even our side has some probes flying daily.
You can open them on the map, just open flight radar, type in balloon, and you'll see several devices. Either this is a continuation of the Nayar Luna project, meaning they haven't stopped. They're still launching, but it's a research topic. They usually have about 4 devices flying, mostly around the States, but some go beyond the borders of the States. There are several European devices. Part of the European space program is being implemented based on stratospheric launches. On one hand, it's about saving costs, and on the other hand, it's about keeping space clean, because there isn't an infinite amount of space up there either. A lot of launches are being made with stratospheric balloons.
And in our country, who is planning to do this, or maybe is already engaged in it, if you think about it? I know, of course, one company, a joint stock company, that is planning to do something for the military.
Well, from the perspective of the approach to long-duration stratospheric balloons, I think our team is leading in all aspects, even though we are just at the beginning of our journey, absolutely. But there are also various groups of young enthusiasts who are drawn to the stratosphere. These include latex materials launches and some small gas shells made of polyethylene that are produced in-house. We're seeing that too. There are many companies that have started working with imported balloons, such as in light of current events, including state ones, such as those at the national level, which really surprised me. This is because the ballooning and stratospheric theme is steadily gaining momentum right now in the industry. There are already at least 4 companies in Russia that are trying to climb onto the armored vehicle, raise the flag, and claim that they are the centers of ballooning in our country, and maybe even in the entire Eurasian region. It's absolutely amazing because truly just a few years ago this topic was completely overlooked. No one saw any potential in it, and it is incredible how things have changed. How the world changes, how opinions change.
Well, everything seems to be cyclical, like electric cars existed 100 years ago. They were the first, and now people are remembering them again. It's the same with airships, really. No one has ever forgotten about ballooning. There are certain triggers that seem to spark public interest.
Well, from the perspective of technological development and the patterns of technological advancement, undoubtedly new achievements in other technological fields and a new approach to the type of technology undoubtedly lead to new results. Lighter materials such as more advanced gas-retaining materials, better and highly efficient welding technologies, improved and innovative measuring and fixing devices, electronics for telemetry, control, and so on.
Yes, it all makes you look at old things in a new way.
In the 1930s, there was no talk of any computer at an altitude of 20 kilometers, but now we can provide good computing power.
But they could easily and effortlessly lift at least 3 people up there. I believe that there is a certain balance being compensated. From a technological standpoint, we've had some breakthroughs. But organizationally, it seems like those guys were more resourceful.
It was truly a time of heroes. The first person in space, the first person on the moon, the first person in the stratosphere, in the Mariana Trench, and elsewhere. So, you know, there was the Nobel airship and the Arctic expedition Chkalov flying over the North Pole. And whenever you get involved in this story, it's always about people's lives. In fact, the risk of losing those lives always mobilizes technology. Right now, we might be in a relatively safe environment, and technical development may not be a matter of survival, but rather a matter of desire. A person wants to develop this field, but they're not doing it because they really need to in order to successfully achieve their goals.
Well, yes, but there's also commerce. Competition is starting.
To be honest, the competition in such specialized fields, which stratospheric technology currently is, if it exists at all, might undoubtedly be in China with its immense population and a vast number of companies. And within countries with populations of hundreds of millions, it's always, in general, a relatively speaking closed story. There are few players, and it's not pure competition. There aren't large numbers here, and there's no real unification. It's always something individual.
And so we told one fairly large country when they were visiting us, an African equatorial country, that in general we would be ready this summer to launch something even from the equator and perhaps even from a ship. We said they would help. So what competition is there in the market? Colleagues, at the moment there's virtually speaking no one.